Let's talk about how we decide between edge computing and CDN caching versus origin server only rendering. Subscribe to the channel and like this video for more great cloud tips. Every extra 100 milliseconds of latency costs you conversion. Every uncached origin hit costs you money and capacity. And when your origin goes down, your entire global audience goes dark. You have two places to answer a request: a machine sitting 10 to 30 milliseconds from the user, or your own origin 100 to 300 milliseconds away, and sometimes offline. Push the response to the edge when content is the same for thousands of people. That is where you get free DDoS absorption and much lower egress bills. Keep the response at the origin when the page is assembled per user. Also keep it home when stale data costs you refunds or support tickets. The rule is simple. Public and repeatable content belongs at the edge. Per user and fast-moving content belongs at home. Almost every real system runs both. These two checklists are not about picking a winner. They are about sorting each workload onto the correct side. This presentation is a condensed version of the complete article on blog.systemsarchitect.io. View the full blog article with more details there. Edge computing and CDN caching. Edge networks copy your content out to points of presence near your users. A request is answered a few milliseconds away, not a continent away. You also inherit the provider's global capacity as your first line of defense. Mark the points below that describe your workload. 4 or more is a strong case for the edge. 1. Content is cacheable. 2. Users are globally distributed. 3. Traffic volume is high. 4. You want built-in DDoS protection. 5. Sub 50 millisecond responses matter. 6. Bandwidth costs need cutting. 7. You are using static site generation. 8. You want to run compute at the edge. 9. API responses are mostly identical. 10. Geographic compliance rules apply. 1. Content is cacheable. Marketing pages, documentation, and product catalogs return the same bytes to everyone. One copy at each edge location serves thousands, and your origin never wakes up. What gets you there? Sensible cache control headers and fingerprinted asset URLs. 2. Users are globally distributed. A single origin in North America adds over 100 milliseconds for users in Asia or Europe. Edge points of presence erase that penalty for anything cacheable. Even uncached requests get faster because the edge holds warm connections back to your origin. 3. Traffic volume is high. Offload turns directly into infrastructure savings at real volume. 10 million requests a day at a 95% hit ratio leaves your origin 500,000. That means a smaller fleet and spikes that no longer force aggressive auto-scaling. 4. You want built-in DDoS protection. The large CDN networks run multi-terabit capacity across hundreds of locations. That absorbs volumetric attacks that would flatten any single origin. Shield Standard is included with CloudFront at no extra charge. 5-point sub 50 millisecond responses matter. A nearby edge location answers in 5 to 30 milliseconds. A distant origin takes 100 to 300. Users read the first as instant and the second as sluggish. 6. Bandwidth costs need cutting. Egress out of compute instances costs materially more per gigabyte than CDN egress. Teams moving terabytes a month often cut that bill by a large fraction. Peering deals between the providers and major ISPs push the cost down further. 7. You are using static site generation. Next.js, Astro, and Hugo produce HTML at build time. It sits at the edge behind long TTLs with zero origin compute per request. Documentation sites, marketing pages, and blogs. Those are the obvious candidates. 8. You want to run compute at the edge. Cloudflare workers and Lambda at edge run request time logic close to the user. Experiment bucketing, geo-redirects, header rewriting. All of it happens without a full trip to the origin. 9. API responses are mostly identical. Product listings, content feeds, popular searches, config endpoints. These return the same payload to most of your users. Short TTLs of 30 to 60 seconds lift most of the load off your API tier. 10. Geographic compliance rules apply. Residency rules can oblige you to serve from inside a specific country. CloudFront supports geographic restriction, and Cloudflare sells regional data localization. Configured properly, a cached copy never rests outside the allowed geography. Origin server-only rendering. Origin-only rendering answers every request from servers you operate. Nothing is ever served from a copy that might have gone stale. What do you get for the extra latency? A single source of truth and one request path to reason about. Mark the points below that describe your workload. If this list collects more marks than the last one, keep the rendering at home. 1. Content is highly personalized. 2. The application needs real-time data. 3. Cache invalidation would be unmanageable. 4. CDN cost would exceed the savings. 5. Strong consistency is required. 6. Every request hits the database. 7. Users sit close to a single region. 8. Debugging needs to stay simple. 9. WebSockets or long polling are core. 10. Regulations mandate controlled processing. 1. Content is highly personalized. Dashboards, social feeds, and account views are assembled per user. Cache that carelessly, and you serve one customer's data to another. That is a security incident, not a performance problem. 2. The application needs real-time data. Trading screens, live scores, chat. These move faster than any TTL you could reasonably set. Even a 1-second window lets someone act on a price that no longer exists. 3. Cache invalidation would be unmanageable. Some platforms change thousands of records every minute. That purge volume outruns what invalidation APIs were built to absorb. When content changes faster than the cache can clear, caching adds bugs instead of removing them. 4. CDN cost would exceed the savings. Below roughly 100,000 requests a day, the offload is worth less than the overhead. One right-sized instance serves that traffic comfortably. At that scale, a cache layer mostly buys you a new category of bug. 5. Strong consistency is required. Balances, inventory counts, and booking availability must reflect current state. Serving something stale here means an oversell or a double booking. The cost lands as refunds, chargebacks, or compliance findings. 6. Every request hits the database. Why does search resist caching? Arbitrary filters and date ranges make the key space effectively infinite. Hit ratios land near 0, so the cache only adds a hop. Running the query is cheaper than storing every possible answer. 7. Users sit close to a single region. Admin panels, back office tools, internal dashboards. These users are already 20 to 50 milliseconds from the origin. Nobody notices the savings, but they do notice the caching bug that ships later. 8. Debugging needs to stay simple. An origin-only path gives you exactly one place to look. Put a CDN in front and you rule out the edge cache, a point of presence, and the browser. One request path also traces cleanly in Datadog or OpenTelemetry. 9. WebSockets or long polling are core. Collaborative editors and game servers hold persistent connections open. CDNs are built around request and response. Those connections are better terminated at your own servers. 10. Regulations mandate controlled processing. Some frameworks require processing and logging inside infrastructure you can audit. Edge locations are shared, multi-tenant infrastructure run by the provider. Encryption in transit does not answer an auditor asking where the request was processed. Sweet spot and hybrid reality. Almost nobody picks one side for everything, and you should not try. Static assets belong on a CDN in every architecture. Public pages cache well at the edge with TTLs from a minute to an hour. Anything authenticated or personalized renders at the origin. So does every mutation where current state is the whole point. Stale while Revalidate bridges the two worlds. It serves the cached copy instantly while a fresh one is fetched behind it. And when personalization is light, edge compute handles it without giving up the cache. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.